So how do you make a mountain? It's a bit of an odd question, isn't it? But for hundreds of years, we've been asking that question to better understand the natural world around us. They do a lot of things. They create rivers, they harbor many of the species of life on Earth, and they can even control the weather. And we have it down for some places. India, for example, is smashing its way into Asia, pushing up the Himalayas. And the Pacific Ocean is tunneling under South America, creating the Andes. But what about Norway, or Greenland, or even Scotland? We have mountains everywhere, but nothing's crashing into anything, nothing's being pushed up. My work focuses on the coastal mountains of Greenland. How did they form, and how have they evolved over time? Now, like all great questions, there's two possible answers. One being that they are recent, i.e. 30 million years old, and were pushed up by some tectonic forcing. While others would suggest they're part of some grander ancient mountain range that was slowly eroded over time to what they are now. But how would you best answer that question? Well, my work focuses on the fact that rocks are cool, not in the sense that they come from deep within the crust to the surface and cool down in temperature. Now, for example, if the rocks that make up a mountain cooled rapidly and fairly recently, you would suggest that the mountain itself formed recently. But if they cooled slowly over a long period of time, you would be able to suggest that the mountain itself was old or part of a much older structure. But how would you measure such a process? And to quote the great Donald Trump, you know what uranium is? It's this thing called nuclear weapons and other things. Well, I use it for other things. Uranium atoms in rocks explode, creating scars across mineral surfaces. If you count the number of scars on the mineral surface plus their length, you can calculate how a rock has cooled. Now, I've taken data from across Greenland, and the results that I have show that a large number of the mountains there are exceptionally old, maybe 400 million years old, and were part of some grand ancient mountain belt that have slowly eroded over time thanks to rivers and glaciers. Now that work can be applied to mountain belts across the world. Scotland, Norway, Canada, the US. It may even explain why Greenland has a massive ice cap sitting on top of it. But what the key thing is that mountains play a huge role in the world around us, and understanding their story helps us better understand the Earth